So how exactly is precipitation formed? Well, all precipitation develops in clouds, and clouds are formed when water vapor in the atmosphere cools and condenses. As the water vapor condenses, it then forms droplets. If the clouds are developed within or move into the part of the atmosphere that is below freezing, then the droplets will form ice crystals. Next, we are going to be talking about the differences in snow, sleet, hail, and rain. First, we are going to talk about how sleet and snow begin as ice crystals. So, as along with ice crystals, they start in high clouds where the air temperature is below freezing. It is the temperature of the atmosphere that they descend through that determines in what form these crystals will reach the ground. Next, we have snowflakes. So snowflakes form when ice crystals stick together as they fall through the cloud. To reach the ground, the snow needs to remain frozen from the cloud to the surface. So if it doesn't remain frozen from the cloud to the surface, then obviously we will not have snowflakes. So next we have sleet, and sleet is a mix of rain and snow when snow falls through a layer of warmer air to the ground. Then we have freezing rain, which forms when raindrops hit surfaces that are below freezing. So if the weather isn't below freezing, then obviously we will not have freezing rain. So why exactly is lifting of air important? Well, without lifting of air, we wouldn't have the creation of clouds nor precipitation. So the lifting of air is very, very important. The first type of lifting that we have is the orographic lift, which this lift occurs when an air mass is forced from a low elevation to a higher elevation as it moves over rising terrain, as you can kind of see in that picture as that describes that. As the air mass gains altitude, it quickly cools down adiabatically, which can raise the relative humidity to 100% and create clouds, and under the right conditions, precipitation as well. Second type of lifting is frontal wedging. Frontal wedging is the process by which cold, dense air acts similarly to a mountain barrier, forcing warmer, less dense air to rise over it. The leading edge of a mass cold air is known as a cold front, and similarly, the leading edge of a mass of warm air is known as a warm front. So this mechanism is associated with cold/warm fronts and cyclones, also known as frontal systems. This usually produces clouds and precipitation with often severe storms or thunderstorms along the cold front. And we will go more into depth on cold fronts, warm fronts, and other types of fronts later on in this presentation. We always hear about these different types of fronts, regarding with the weather. But what do these fronts really mean? I'm going to discuss 4 different fronts: the warm front, the cold front, the occluded front, and the stationary front. So what exactly is an occluded front? Well, these form when a warm air mass gets caught between 2 cold air masses. And as you can see in the picture, that is exactly what is happening. The warm air mass rises as the cool air masses push and meet in the middle. And that description, that I drew, definitely proves that. The temperature with this type of front, the temperature typically drops as the warm air mass is occluded or cut off from the ground and pushed upward. These can bring strong winds and heavy precipitation. Next, we have the stationary front. So the stationary front forms when cold and warm air meet and neither mass has the force to move the other. So they remain standstill. This picture describes that. So they are going to meet, and that is why they cannot move each other. So when the warm and cold air meet, clouds and fog form, and it may rain or snow. Can bring many days of clouds and precipitation. So the warm front is something that we're probably more familiar with from the last 2, and the warm front forms when a moist, warm air mass slides up and over a cold air mass. And in this example, you can tell by the arrows that is actually describing that. As the warm air mass rises, it condenses into a broad area of clouds. A warm front brings gentle rain or light snow, followed by warmer, milder weather. So next we have the cold front. A cold front forms when a cold air mass pushes into a warmer air mass. Cold fronts can produce dramatic changes in the weather. They move fast, honestly, when reading up to twice as fast as a warm front. As a cold front moves into an area, the heavier cool air pushes under the lighter warm air, causing it to rise up in the troposphere. Lifted warm air ahead of the front produces cumulus or cumulus clouds and thunderstorms.